Hello, everyone. Good morning. My name, like Aaron said, was Addison Ashworth. I'm a software developer at the University of Texas at Austin Libraries. We'd like to share some insights into the challenges we face in maintaining our current repositories and a little bit about how we're using Fedora 6 to overcome them. So first, a little bit about us. Here at Austin, we maintain about a dozen repositories, depending on how you count them. Some of them are as old as 15 years. Like all repositories, probably, that you guys also host, each one exists with the goal of preserving and circulating the data contained inside. We strive to build systems that support our mission of being an organization that advances teaching, catalyzes research, and democratizes learning in order to develop critical thinkers and global citizens. And repositories are a great way to do that. As we try to keep the lights on and the data intact for all of our repositories, we find ourselves running into the same problems, updating every few years. And we are looking for ways to streamline that process. We'd like upgrading old repositories to feel more like putting a new coat of paint on a home with a solid foundation than our current process, which, following the same analogy, is more like building a second nearly identical home right next door and then moving all the furniture over. Based on our experience maintaining and deploying repositories and with the future in mind, we're rethinking our repositories with Fedora 6 as the foundation. To explain how Fedora helps us solve these problems, we'll start with some context on how we've handled building and upgrading repositories so far. So many of our repositories are centered around an all-in-one digital asset management system, Islandora for many of them, that enables our librarians to manage their collections. We like the technologies provided in these sorts of packages, Solr, some sort of GUI, and of course, Fedora, but we've run into several problems that influence their sustainability for us in the long term, particularly when it comes time to upgrade. The first issue we are seeing is that we have to make a lot of customizations for each repository, which is normal. The real problem is more maintaining all those changes through the upgrade process. Due to how intertwined the stack is and how significant the changes between versions can be, upgrading often pretty much breaks all of our changes and configurations. As for the data stored inside each repository, it's usually in formats that are difficult to back up and to access and difficult to circulate outside of the tools provided by these these built-in content management systems. Once again, not a huge deal in and of itself if the data never had to move, but upgrading causes us to undergo a long migration process from the old to the new repository. Overall, upgrading is time-consuming and a big lift for our librarians and developers. And maybe you can already see how implementing a standards-based core would help us to alleviate these issues. Let's dive a little deeper, starting with the kinds of customizations we're dealing with. Every repository has its own control vocabulary, search requirements, methods of distribution, validation, and metadata. I'm sure everyone here is familiar. These features help our stakeholders automate their work and maintain uniformity. I'm sure everybody else here communicates all these project requirements perfectly the first time, and you never have to make any changes halfway through a project. But for us, nailing down these requirements and creating software to support them can be an ordeal, and it's very much an iterative process. It requires a lot of time from all stakeholders and even more communication every step of the way. But when all is said and done, we apply the customizations in the form of configs, custom side apps or microservices, sometimes entirely separate front ends in addition outside of the content management system, like the ones pictured here. This is all necessary work and can't be avoided, but during upgrades, these changes don't have a great survival rate. Delivering fewer features after an upgrade is a pretty hard sell to our stakeholders, so of course we re-implement them all. Some of our repositories are pretty old and have had features tacked on over the years that weren't really accommodated for in their original design. So the repositories are not just an all-in-one CMS, but an ecosystem that relies on the CMS as a core and all of our side configurations trying to pry inside and steal its data. It ends up being not so all-in-one as we try to swap out parts that probably we really shouldn't. It's a lot of work to get these tweaks perfect, and it's work we would really rather not repeat. So in talking about the data in our repositories, in some of them, our repositories, we're trying to extend the functionality of the CMS and expose the data externally to other front ends that aren't built in. We have some repositories set up that even share one CMS, but then the data can be exported to one or several front ends. Making the content of our repositories public and trying to circumvent the use of the built-in like Drupal front ends that Islandora uses has been a problem for us. And because the raw data is stored in proprietary formats, even if we expose the underlying tables and data structures, isn't all that meaningful to these other front ends that we're using. Additionally, because in our old repositories, the data formats aren't standardized and are very susceptible to change between major versions, not to mention we wait really long to do this upgrade, mostly until we have to. We usually have to completely extract, transform, and load it into this new system when we're upgrading. Often new metadata is added during this process to keep track of previous unique identifiers generated during all the previous app versions, and new functionality is added so that the new system can honor these old citations, UUIDs, and links. So because of all these issues, writing a lot of customizations because our needs have grown beyond the all-in-one solutions, having to migrate the data from the old to the new, and just waiting a long time between updates, it is difficult for us to upgrade in place. For us, this means upgrading from a soon-to-be deprecated stack usually follows this pattern. Spin up the newest version of our stack with the latest updates, then we rewrite all those customizations and microservices for the new app. Once we're happy that it once again meets the needs of our repository, we migrate the data from the previous system. Though we have the previous app as an example, a lot of the nuance behind the configurations is lost over the years. So we rely heavily on stakeholders communicating their needs again. This can lead to inconsistencies in archive data that has survived multiple rewrites, and the new system has to accommodate for these inconsistencies or remove them. This also is a really time-consuming process for both the developers and the librarians. The whole thing takes months, which means in order for us to stay ahead of all the deprecating versions of Drupal and other technologies on our stack for all of our repositories, we have to plan these upgrades pretty far in advance. So here's kind of a simplified diagram of the kind of repository architecture we've recently upgraded. All the files are ingested into Islandora via batch processes or the editor. What you see is what you get editor, but not served by Drupal at all to the end users. Islandora, in this case, is more of a staging area used for Fedora's preservation, helps us create derivatives and does some metadata validation. Instead of using Drupal to serve the files, we have a separate publishing app that exports the assets from Drupal to a more public Solr and file mount. A Blacklight front end then provides the final browsing experience, or in this case, several Blacklight front ends we can publish to a couple different areas. As you can imagine, having two sources of the same data leaves all kind of room for inconsistencies and problems, and the whole publishing process is not very robust. So where we're going, like any tool, Islandora has worked for us when we used it as intended, but in many cases we are using it just where it doesn't make sense at all. Likely because it was familiar to us and our team, it was our golden hammer. and every repository we built looked like a nail. But in reality, many of our repositories have outgrown it, and all the tacked on functionality we've added over the years is making upgrading harder every time. And that is really the primary reason we are rethinking our architecture. We have liked using all-in-one solutions, and they have helped us create repositories quickly, but blindly using what was familiar to us in the past has resulted in some convoluted repos, which are difficult to maintain. To solve the issues we're having, many of which are self-inflicted, we are setting out to find a better way. When we started making plans to upgrade one of our longest standing repositories, the Archive of Indigenous Languages of Latin America, or as we call it, ILA for short, we wanted to take a step back and rethink the repository from the bottom up, knowing it has been around for 15 years and will likely last another 15. At its core, we knew we wanted a single authority for the binaries of ILA that all components could seamlessly access. Our aim was to establish a modular API-driven ecosystem that allowed for convenient updates and replacements of the individual components. Because of its preservation tools and robust API, we turned to Fedora to begin prototyping. As we dug into Fedora's offering, we were especially excited about the fact that all the data was stored in a standard space format, OCFL, to hard disks or S3 storage. We like how robust Fedora is, as I'm sure y'all are well aware. Even if our Kubernetes or container running Fedora had some sort of, catastrophic failure, it can be completely restored or re-indexed from disk. Additionally, having the ability to access, understand, and manipulate the data preserved in Fedora gives a huge confidence boost. And we just dove right in and started prototyping a repository around it. Building around the OCFL structure, abstracted away by Fedora's API, allows us to focus on the business logic and the front-end functionality of a repository and build an ecosystem where each piece can be upgraded independently. We have high hopes that because the data can be accessed by Fedora's API or directly from disk if needed, we won't have to move it when it comes time to do our next upgrade. The data is already where it needs to be, with preservation tools and version control built in. On the right, it's an infographic we use to communicate to our stakeholders the layers of this new architecture. With OCFL as the foundation, managed by Fedora, we use APIs to connect each layer and meet the business requirements for ILA. Front-end connect to the back-end, implementing business logic, and several file-serving services also live around that layer that all communicate exclusively with Fedora's API to access the repository's data. So with the goal of migrating ILA's data into this application agnostic format that any future version of the repository could use, we split its architecture into more modular containers, each of which is a square on this slide. Starting with the bottom layer, or on this graphic, the left-hand side, we're using Fedora 6, the FC repo Docker image, and attached a file mount to it. While we were comfortable with how it was configured in our environment, after we were comfortable with how it was configured in our environment, we implemented the Fedora API in a technology our team was already comfortable with, which was another advantage of building it yourself, I guess. But we chose Python and the Django REST framework. This backend provides all the endpoints for CRUD operations, storage of metadata, creation of derivatives, Solar Search, everything that is beyond Fedora. It abstracts these workflows away from the front end. Quick caveat as I show some of our new ILA pages. We're still working on the ILA upgrade, so these are all work in progress pictures. We're hoping to switch over the URL to the new site in December. So if you visit now, you will still see our lovely mustard yellow ILA site on the right here. To support stakeholders overseeing the repository and to provide a portal for public viewing, we developed a front end using a modern web framework, Next.js, a React framework. But if stakeholders wanted a new front end tomorrow, we could completely replace it with something else like Blacklight without disrupting the back end or OCFL. Back to the diagram, we were able to offload the burden of serving files from our backend kind of horizontally to technologies like Cantaloupe, Image Server, Wowza, Nginx, which we use in conjunction with the Clover IIIF viewer on the front end, all of which communicate directly through Fedora's API. We knew before we started that if these services were for some reason incompatible with Fedora's API, we could at least attach them to the same disk volume as Fedora and serve files that way, a method that has worked for us in previous projects. But it didn't come to that, and all of our containers talk to Fedora if they want to access something from the OCFL directory. This way, Fedora acts as the cornerstone of our repository, both preserves and serves the files stored within. We anticipate that splitting the data, business logic, and front end in this way will make upgrading each piece much easier in the future. And we will be using Fedora as the base of rebuilds for other repositories as well. Now to show off a little bit of what Fedora has enabled us to do, here is our work in progress front end. And this is a list of collections in the repository. The sky has really been the limit here in terms of customization. We've had a lot of fun exploring unique ways of showing off what is contained in the repository. For example, we experimented with some flags and color coding based on languages involved. Because this repository is primarily about languages, it made sense to us. One requirement of the repository is that the entire site and a lot of the metadata stored needed to be shown in English, Spanish, and Portuguese. You can see the language selector on the top right. This was not too big a hurdle, leveraging a modern framework like React. The front end follows the structure we have in OCFL pretty closely. We have a few layers of containers and then groupings of binaries and some limited metadata. So Fedora really enables us to choose the best tools for each repository. Here is some more front end. It's a collection, an object in the collection that is using the Clover IIIF viewer to show off its content. We can kind of group and show off objects however the stakeholders prefer. Previously, it looked more like this, where you'd have to click on each file in order to see it, which got tedious with larger collections. So overall, Fedora has helped us to make the content of our repository more accessible while maintaining a single authority, and we don't have to copy it or house it in multiple locations like we were doing with our previous architecture. On the left, we have kind of the Django REST framework GUI. It was nice using this because it allowed us to kind of simulate endpoints and provide a visualization of our endpoints. Once again, use Django to implement the Fedora API. On the right-hand side, you can see an example item bundled with its IIIF manifest. Though we didn't get into RDF much on this project, we definitely took advantage of the hierarchy that Fedora provides to give our data some basic relationships and group-related binaries into containers. Looking forward to the future, we experimented with other features of Fedora that didn't quite make the cut for this project due to time constraints and, well, just us not knowing a lot of Fedora before we started this project. But we'll certainly revisit these for future repositories or enhancements. The more we dove into Fedora, the more we appreciated the design philosophies that it is built around. Things like being able to index from hard disk in case of failures or triggering logic off of event streams with Camel Toolbox will certainly be driving design choices for future repositories. We connected Fedora to S3 storage, but we used an implementation of S3 from NetApp called ONTAP S3 and did not use Amazon S3. While it seemed close to working, the S3 implementation that ONTAP implements was different enough from what Fedora was expecting that it didn't quite work out of the box. We swapped back to hard disk storage to finish off the project. Maybe we will revisit S3 in the future. Fedora's got a built-in authorization and authentication framework, also something we didn't take a large advantage of Our Fedora is running behind a VPN that other services can talk to, so it isn't being directly hit by the front end. So only the most basic auth is used here. Some of our repositories have item level permissions. It could be interesting to use Fedora's authorization framework to make it even more of a central authority in the future. For Isla, we really only stored binaries inside Fedora. This is a missed opportunity to simplify our architecture further by having all our metadata in standards-based formats like RDF and linked data. We hope to reap the same benefits that we are currently doing for the binaries. Our organization has little experience working with these formats. We'll have to work to understand how to efficiently use RDF to meet our goals. We're excited to see how others are using RDF in the linked data platform. All these features enable us and point us towards building robust API-driven ecosystems of applications that rely on standards-based formats. I would dare to say that our Fedora core repository has gone well, but hopefully we can take advantage of more of these design patterns in the future. We learned a lot about Fedora this first time around and are excited to draw inspiration from how you guys are using Fedora too. With its integrated preservation tools, standardized storage, and robust API, Fedora 6 was our central choice for Isla. Our goal is to use Fedora 6 as the cornerstone of our future repositories too, as an authoritative hub that all our other services can access. Building our archives with Fedora as a base will reduce the amount of time spent on migration efforts by preserving data in OCFL independent of the business logic and front ends layered on top of it. That's pretty much it. We have some time left for questions. I'll try my best to answer them, but if I can't or we don't get to your question, please reach out to us here, this email. If you would like to see Isla, you can visit this link, though it won't be changed over until sometime in December. We're still working on it. So thank you.